Okay, hello, I am Damien Edwards. I'm a program manager on the ASP.NET team, and getting towards the end of the day now. I'm going to talk to you about SignalR, which I like to do. Today we're going to focus on something I haven't spoken much about on SignalR before. We only have 30 minutes. Feel free to ask questions as we go along. But I'm going to try and cover a little bit of using the SignalR.NET client, and in this case specifically from a Windows Phone application. I have a very simple chat application, we have a web client, we have a .NET client, and we're going to have a look at the differences between the two. What's the same, what are the type of code that you need to write to try and get a reliable experience. And let's just dive into the code right now and take a look. Okay, so I have Visual Studio running here, and I have an app that I've been working on today, which is my chat application. If we go over to my browser here, let's see if it's still running. It seems to be. I have a pretty typical sort of, canonical, simple SignalR chat application. When I launch the browser, it tells me that I've joined. I can go hello, hit enter, and I'm getting it seen by all other users. I can prove that it's actually SignalR by opening another browser. Let's paste that URL in, and I can test from the right, and you can see that it's pretty standard SignalR chat. You've probably seen me write it 100 times. So the other thing I've done is I've written a Windows Phone client. So over here I have a SignalR chat deployed to my emulator. And it's a pretty similar interface. You can see over here on the left now that it says phone joined. So already you can see there's a little bit of logic in my app that can detect when I have a browser joined versus when I have the phone joining, and and showing a different message to people when that happens. As you can imagine, I can sort of hit test over here, hit send, and it appears in the left in the browser, and it appears in the right. If I say, hey there phone, from over here, hit enter, it appears on both. So it works like you would expect. It's SignalR, it's real time between two connections, they're both connected to the same server. It's just that this time one of them is running in Windows Phone using the SignalR.NET client, and the other one is the more typical JavaScript client you've seen. So I've done a couple of interesting things in this application that I haven't done before in demos, so hopefully there's some interesting stuff for us to talk about. So let's go and have a look at let's start out by looking at the server just to prove to you that really nothing has changed from what you may have usually seen. So here's my server hub. It's a chat hub, derives from hub. I've given it an explicit name called chat up there with the hub name property. And then I'm overriding on connected so that when a new person or a new connection joins this hub, I'm going to go ahead and tell everybody else or everyone on the hub that someone has joined. And you can see that I'm using null coalescing here to make sure that, hey, if they're authenticated, let's show them their name. Otherwise, let's just call them anonymous. And then I have a single message. Hey, sorry, a single method. I just want to be able to send a message. Really, really simple, almost a relay hub. The client calls the server with content, and the server just immediately turns around and sends it back out to everybody else. There's really not much logic going on in here. So let's have a look at my web client, because I've done a few things here that are interesting this time. Okay, so here's my UI logic, my UI structure. It's pretty simple. You saw it. It's a form with a text box and a submit button, and then I have the UL here where I'm going to show the messages as they come in, and then finally I have a status P. Now what's interesting here, you might note, is that I am not giving my elements IDs. Usually when I do this demo, I would go and write a bunch of JavaScript code that looks up these elements from the DOM using jQuery, and then I hook up sort of everything with my SignalR code and my UI using jQuery. Well, I haven't done that this time. I've actually used Angular. So I'm going to take this opportunity just to look at a little bit of how you might integrate SignalR with a more structured client web framework like Angular. And I did that because when we get to looking at the .NET client, you'll see that I did a similar approach in the .NET client, which is very popular. The model view model, or MVVM style, is a pretty popular sort of model for doing client application development in .NET, and certainly Angular in JavaScript and HTML is a very similar paradigm. So I figured, hey, let's try and see if we can see some similarities here. So the first thing we have to do to get Angular to work is I've got ng app decorated up here in HTML. Now this is not an Angular talk, so I'm not going to delve too much into Angular, but I'll just give you the quick basics. This denotes that my Angular application is encompassed in the entirety of this page, which is why I'm the HTML element, and it's called chat. And then the first view is this div here. And I only have one view in this application. It's pretty basic. So I have chat controller as VM that says to Angular, hey, this is a view. The name of its controller that I need you to give me is the chat controller, and I want you to give it an alias or a variable name, if you like, of VM. So VM will now be available to me inside this view for me to interact with the controller. Now I use VM because it's short for view model, and I like to think of the controller as a view model. John Papa just did a really good blog post on this pattern, and this is becoming more and more common in Angular apps from what I can tell. So I have a form which contains my text box and my button. In this case, I'm using ng submit, which is effectively, this is what's called an Angular directive, just like ng controller. And in this case, ng submit simply says, when the submit event of the form element is raised, go ahead and execute this expression. In this case, the expression is viewModel.sendMessage. So you can probably guess there's a send message function hanging off my controller, which is acting as my view model. So that's pretty straightforward. If we go down to the text box now, where I type in the text to send my message, I'm using ng model, which is another directive that tells Angular, hey, where am I going to get the data from the view model, or from the controller, associated with this element. So in this case, I'm saying, hey, the model for input, so this text box is relating to my message property on my view model. So that's fairly straightforward. So if I type in the text box, it's going to update the message property on my view model. And if the message property gets updated, my text box will get updated. It's two-way data binding. And then the submit button is just a submit button. So there's not a lot of logic here. I don't have a click handle or anything like that because I've hooked up to the form submit button. But I do have an ng disabled, so I don't want that submit button to be available. I don't want the form to be able to be clicked and submitted until a bunch of things are true. And I usually do this in my demos. I usually say, hey, don't enable the UI until the SignalR connection has actually started. Because otherwise you can get to the situation where people can start clicking buttons as soon as they appear in the form. But the connection may not be started yet, and you'll start getting errors because everything's asynchronous. So this is just an example of how you can synchronize the asynchronous starting of a SignalR connection with the availability of the UI that allows the user to interact with that connection. So I'm using ng disabled, which basically says, hey, if there is an error on the message field on chat form, so you can see the form is called chat form, you can see that the input up here is called message. So if this input element here has an error, and that error is that it's required and it's currently active, so that means you haven't typed it in, or the property on the VM called ready is not true, bang, then disable the button. Okay, you can't use it until those two things tickety-boo. All right, and then down here we have the place where I'm actually going to show the messages. It's just a UL with a repeat directive, li. This is the Angular expression that you'll use. It's a sort of a specific syntax. It's a little bit like link, not really, but it's kind of the same idea. It's a bunch of structured syntax that you can use inside certain directives like ng repeat, and Angular understands this. And obviously you'll have to read the documentation, know what it is, but the first one's pretty obvious, for message in vm.messages, so I have an array called messages. For each one called message, go ahead and repeat this li element, and then here is an example of a data binding expression. So obviously message will be echoed out on the screen here. Don't worry too much about this track by index. This is just a way of telling Angular how to uniquely identify every element that's inside this repeated area. All right, so that's the markup. Let's have a quick look at the code. So here's my declaring my Angular module. So Angular splits stuff into module, and the first module is my app, which I called chat. I have two things hanging off that. I have a factory and I have a controller. So the controller is the thing that that marries to the UI. It connects to the view, and I call that chat controller, and you'll remember I refer to it as chat controller up here. So I create a controller by calling controller. The controller is effectively just this function. Okay, so JavaScript, great language. There's a lot of interesting things though. You can't really treat it like other languages that might seem similar, but in this case, this function effectively acts as the controller. My VM member again, which I'm kind of using that same name that I did from the UI. Again, read John Papa's article on that. It's really, really good. And then a bunch of stuff going on. So here I am setting up some properties on my view model. Here's my ready property, my status, my message, and my messages. So these are the properties that I was referring to up here in the various directives and binding statements. Here's vm.status. here's vm.messages, here's vm.message, and so on. Here I'm just initializing those to their initial states. I'm then adding the send message function to my VM, and if I scroll back up, you'll remember that ng submit was calling send message. And then I'm calling something called set ready, which we'll look at in a second. And then I'm doing a bunch of stuff that might look familiar if you've done SignalR before. There's an on method there, and I'm handling events being raised. But because this is Angular, I've done things a little bit differently. So let's have a look at what I've done. So if I go up to my factory here, this factory method is essentially creating a reusable service for the rest of my Angular application. Now, in this case, I only have one controller, but I've chosen to separate these things because this is a very typical design that you see when using something like SignalR with Angular. So the idea is I'm creating a service within inside my application called ChatHub. And a service is just an object. It's just a class, effectively, if you're used to server programming, and it has stuff on it that I can do. It has methods and it has properties. So I have a thing called ChatHub, and as you can see from this code here, ChatHub is really just a wrapper around the normal SignalR hub functionality. And so I'm getting a handle on the SignalR hub here, $.connection.chat. I am creating the client-side methods for that, as you would normally do in SignalR. And so, for instance, when new message is called, I'm then going to go off and broadcast that throughout my Angular app using Angular's own pub/sub utility. So Angular works with this concept of scopes. Now, you don't really have to understand scopes, except that they're kind of like the model for your entire application, and they're hierarchical. So they all start with this thing called the $root scope, and then all the scopes that are created later on in your application in different views and inside different controllers, they all ultimately inherit from the root scope. And you can even nest controllers in views so that you can have one scope then emit another scope and so on. And you can communicate between those scopes using pub/sub, which is what I'm doing here. So root scope is the root of the scope for my entire application. And because there's only one of these factories, it's effectively a singleton, I can very easily here say when new message is called via SignalR from the server, go ahead and broadcast the result of that throughout my application, just calling $root scope $broadcast. Same again for user joined. I got a little bit of code here to handle disconnection, which I'll talk about later. And then I go ahead and return an object, the service, that the rest of my Angular application will use. So in this case, I'm returning this thing. It has a property called server, which I'm mapping directly to just hub.server. This allows my controller to call methods on the server via SignalR. And then it has a property called ready, which is at the moment the result of starting the connection. So this is a promise, similar to a task in .NET. And again, if you've done SignalR before, you'll know that a lot of things are asynchronous. You call .start, and then if you want to wait until .start is finished, you have to chain that with something like a .then. So in this case, because the connection is not near my UI code, because the UI code is in the controller, I'm passing it around through this service that's being injected in by Angular. So I have a task that represents when the connection is ready to use. You can probably see where this is going. So that's my service. And then we go down to my controller. This is the thing, this is a bit of code that actually controls the HTML effectively, that little bit of view. It takes in that chat hub. So if we go up here, that factory was registered with the word chat hub, the name chat hub. And so this controller has access to that instance. There's only one of them. As I said, it's a singleton. By way of it being injected. So Angular uses dependency injection, which is a great thing. And so I can just get that here, and I don't have to worry about where it came from or who provided it. I don't really have to deal with SignalR code inside my controller. I'm just dealing with the contract of ChatHub, which, as we saw, is just this service here. It's very, very small. It also means that things like the controller are more easily testable, which again is one of the tenets of Angular. So, okay, what are we doing inside Chat Controller? So we had a quick look at that before. Now that we know what ChatHub is, it's really just a wrapper around the server-based methods in my hub and that ready promise that tells me when the connection is ready to go. You can see that down here, I have a method called setReady, which I call just after I set up my VM. Let's have a look at what setReady does. It chains a function off ChatHub's ready. So remember, ChatHub.ready there is referring to this thing up here, okay? And that was set to the result of calling start. So this ready promise won't be resolved until the connection has started. And when that happens, I'll go ahead and set the ready property on my view model to true, meaning that my UI now can respond to that thanks to data binding. And if a message was passed into the setReady function when it was called, I'll go ahead and push that message into the UI. And then I'll call scope.apply, which is basically tell Angular that I made changes to the view model. Now, Angular will automatically detect there are changes to the view model if you make them through Angular's UI. Through Angular's APIs, but because I'm using SignalR and SignalR isn't a native Angular component, I have to tell Angular when I'm done updating my view model so that it can force its update cycles. That's what scope.apply does. So all we've done here is say when the connection is ready, set a flag on my VM so my UI will turn on, and then tell Angular to go ahead and update the UI. And that's pretty much it. So it's the same type of app you've seen me write before, but it's a little more structured now with things a little bit more separated using a framework like Angular. And so while there's a little bit more JavaScript code than there would be here usually, not that much more, but a little bit more, it means that my declarative code, my UI, is much cleaner, right? There's no IDs there. I'm not looking them up in the DOM. It's not as brittle. I only do, things are only updated by way of data binding and data binding expressions. If you've used something like Knockout, this will also be somewhat familiar to you. Okay, so that's my HTML application. Let's go and look at the .NET side of this now. So here is the main page. Here's the chat view that we saw. Let me bring up the app here so you can see it, okay? And again, I've chosen to try and use an MVVM type approach to this. Now, I am not a Windows Phone developer by any stretch of the imagination. I think this is actually the first Windows Phone application I've ever written, and I wrote it this morning, so bear with me. But I have done a bit of WPF in my time, and so I am familiar with the concept of XAML and how data binding works and the general MVVM principle. So hopefully, this is put together in such a way that will be meaningful to people who do actually do real Windows Phone applications. Let me show you the code behind for this, because it's really simple. All I'm doing is setting data context to an instance of new chat model. That's the only code that's in the code behind of this form. So again, one of the principles of MVVM is that we remove a lot of that cruft code from the UI, and I'm moving all that into a view model. And that's my chat view model class. So I don't need to look at that again. You can see that there's really no code in the view. Everything going on in the view here is done by way of data binding. And Silverlight and WPF have very rich data binding, as do Windows Store apps, which everything I'm showing you here would be equally applicable to. Obviously, because this is not JavaScript, I have to use a different SignalR client. So if we have a look at what is installed in here, this is my project over here. Let me zoom into this particular project so you can see it a bit better. If I scroll down inside my Silverlight phone app to packages.config, here are the packages that I installed. Now, the only package I actually explicitly installed was that first one. I just went to NuGet and installed Microsoft ASP.NET.SignalR.Client, which contains all the various flavors of our .NET client. Now, in this case, it would have used the assembly that was compiled for this type of application, which is a Silverlight Windows Phone 8.1 application. But that package actually contains many .NET assemblies. It has ones for full .NET on .NET 4 on the desktop and .NET 4.5 on the desktop. It has flavors for Xamarin, it has a portable class library which can be used in Silverlight 5, and so on and so forth. And actually over time, it's conceivable that this package will have more and more assemblies placed into it as we light up more native features for the .NET client on the various .NET platforms. So I can tell you that right now, the best transport that you can use with SignalR for Windows Phone is unfortunately long polling. The Windows Phone network stack has a bit of a history of not being particularly good at doing HTTP streaming from .NET code. And so at the moment I'm using long polling, and I'll show you the code for that. It works perfectly well, but what we're doing in SignalR 2.2 is we're doing the work to actually light up WebSockets with inside the .NET client on Windows Phone 8.1 and Windows Store apps for 8.1, and also in Xamarin clients. So obviously our .NET client can work in the Xamarin suite of stuff as well. So if you're doing Xamarin for iOS, Android, or Mac, you can use our NuGet package. It'll work perfectly fine. And moving forward, you'll get WebSocket support for that too very shortly in a new version. But for this demo, I'm using long polling because it's the one that works the most reliably. And you can see that because down the bottom of the page here, I've got connected to this web address via long polling because I like to see that. Okay, so the UI is fairly boring. It's just some XAML with some data binding. There's really not much to show in here. So let's go to where the meat of the action is, and that's in my chat view model, which is this class here. Now, I did find this code quite a bit harder to write, I must admit, than the JavaScript code. I've written a lot of .NET code in my time. I've written a fair bit of code in SignalR, but I did find that doing client-based development with an asynchronous connection, which is what SignalR is easier from JavaScript because of its single-threaded nature. In .NET, you have to be careful, especially in the UI, because we're going to be raising things from background threads as they come in off the network, and you have to be mindful of that. So let's have a look at what I did. So here's my chat view model, which implements iNotify property change. Pretty standard .NET XAML sort of view model stuff. Passed in the dispatcher so I can dispatch back onto the UI thread. I've got a send message command, which if I go back here, my button is bound to. If we go over to here, you can see the command for the button is bound to the send message command. So again, very MVVM focused. I'm not creating event handlers and doing all the type of marshalling between code and the back end and controls. Everything is done by way of the primitives available to me in XAML to set up MVVM. My messages property is an observable collection of received message. In JavaScript, that was just a standard array, but in .NET, I have to use observable. And then I have a property called status, which is shown on the screen. If we go over here, that's that little status bar text across the bottom. Okay, and then I go off and I call connect. Connect is asynchronous, which is why I'm capturing the resultant task in a variable called ignore, because I actually don't want to honor, I don't want to look at the task that's coming back from connect inside the constructor. So I just, to get around the compiler warning, because if I remove that, the compiler will give me a warning that I'm calling a task returning method and not calling a wait on it. But because I'm in a constructor, I really can't do that, so I'm just going to ignore it by doing that. But that's fine, because connect does a whole bunch of stuff, and it happily chugs along in the background when it has to until it's ready. So what are we doing? I've got a little bit of lock synchronization going on here. I'm not going to talk about that too much, but you do have to be mindful about things that are going on in parallel in .NET, especially in client app development when you're using SignalR or any type of network stack. So if hub connection is not null and the state is not disconnected, then I'm just going to bail out. This is to protect against connect being called more than once. Now in this particular application, I haven't actually hooked up the connect method to UI just explicitly, so it's kind of hard for it to run more than once, but this is being very, very careful because the last thing I want is for my app just to crash because two calls to connect happen simultaneously. Go ahead and create the hub connection. Go ahead and hook up some event handlers. So again, fairly similar to the JavaScript client, except it's more .NET-y. I create my hub connection with the URL. I want to be notified if it goes into the reconnecting state because I set the can send flag to false, which in turn updates the UI so that you can't hit that send button because you can't send if the connection isn't up. And I also update the status message to tell me that the connection is reconnecting. So these are the type of things that we don't typically show in sort of our 101 SignalR demo, but these really the type of things we do recommend you do if you're building a real application using SignalR. You have to deal with the fact that the connection can go up and down, and the user may get a little confused if they're using the application, then suddenly things don't work because you're not telling them that they're currently in that transient state. So this is how you do that. We have events to do that. Reconnecting, there's the state changed event, which fires for any type of state change on the client. In this case, all I care about is if the old state was reconnecting and now we're connected again, go ahead and reset the status to say that we're connected again and set that can send flag to true. So that's when we start reconnecting, and this is when we're done. If the connection gets closed, meaning that it didn't go into reconnecting, it tried to reconnect and eventually gave up after the timeout. It's about 30 seconds by default. Then the connection is done at that point. It won't automatically reconnect. And this is a really common question we get. SignalR will try to reconnect for a portion of time. The time has a default value and you can change it, but we generally recommend that you don't. What we recommend you do is you handle these events in the client. You handle the event that tells you that the connection has closed. Then you show some type of UI. In my case, I'm locking the UI so that you can't send by setting my can send flag to false. I'm changing the status message to say, hey, the connection went away, it's going to reconnect in a little bit. Then I wait 3 seconds. I just picked 3 seconds out of the air. You can do whatever makes sense for you. This is to avoid having, if you have thousands of clients connected at once and for whatever reason your network blips on the server and they all get disconnected at once, this at least will prevent them immediately trying to reconnect. It'll give them a little bit of time before they try again. And then after that, I call connect again, and I'm going to ignore the task again. So this method looks reentrant and recursive, but it actually isn't, because this delegate here is an event handler. Okay, this is an anonymous delegate assigned to this event handler. So by the time connect is being called here, I'm actually not inside this connect stack anymore. So it looks reentrant, but it's not. Okay. All right, so I call connect. after a 3-second delay if the connection gets closed for some reason. That helps me get a more reliable user experience, and I update the UI on the way. Then I go ahead and create my hub proxy by calling create hub proxy for chat. In JavaScript, we get that nice automatic proxy because we generate JavaScript on the fly. Obviously in .NET, you don't get that. You have to manually create the proxy by giving us the name. It also means that you have to manually, there aren't methods that we generate for you. You have to know that the method names that the servers are going to try and invoke. So if we go back to Chat Hub on the server, we can see that it's trying to call methods called user joined and new message. So I have to handle those two events essentially, or client invocation requests on my hub proxy. And I do that by way of the on method, on user joined. I'm going to get a string as denoted by that type argument called username. And when that happens, I go ahead and add a new message to the messages collection. The messages is a property on my view model, which is bound to my UI. So as soon as I do that, it's going to update in the UI. And similarly, if a new message arrives, I do a very similar thing. I just add a new receive message to messages. Now, some of you might be going, oh, but when I had to do this with .NET, I had to manually dispatch this back onto the UI thread using something like dispatcher.beginInvoke. Now, you do have to do that. And to be clear, I was doing that for the first couple hours of writing this app, and then I got sick of it. So what I did is I created a little wrapper around the hub proxy that we give you called a dispatching hub proxy. And you may have noticed this method over here that I'm calling after I call create hub proxy. So I created an extension method called using dispatcher that you can call on iHub proxy. So create hub proxy is from SignalR. It gives you an iHub proxy. Then I wrote an extension method called using dispatcher, which gives me a dispatching hub proxy, which will use the dispatcher that you give it. And this is the Silverlight WPF dispatcher in this application. If I go into using dispatcher, it's very simple, just creates a new dispatching hub proxy, passing in the original proxy and the dispatcher. And if I go into dispatching hub proxy, most of it just calls right through to the hub proxy that you gave it, right? There's really not much custom logic here. The only custom logic is down here in the on overload. So I've replaced the default on implementations, which is where you hook up those client handlers. And instead of just doing executing the action in line, you can see I'm calling dispatcher.beginInvoke. It just means I don't have to put it throughout my view models. I can just deal with that inside the hub proxy itself because I know the hub proxy is being used in a threaded environment like Silverlight. And then after I've done that, I set the status to connecting, and then I enter a while true loop that says, keep trying to connect until it works. So this is another thing, another pattern that we recommend people do. Don't just call start and expect it to work. You know, at the time your application starts up, maybe the server isn't currently available. So what you want to do is go into a retry loop, let the people, have it call start over and over again, handling any errors that take place until such time that it works. Maybe you want to have a failsafe here so that it doesn't go forever. Maybe, you know, start 10 times or something like that and show an appropriate message. But for the sake of this demo, I'm just saying, hey, while true, keep calling start with a wait. A wait makes this much easier. Until that works, and then break. Otherwise, catch the exception, update the status message so that people know that there's an error, then wait 3 seconds and then try again. Okay. There's a question, is it possible to get this demo code? Absolutely. After this talk, I will post this demo code up on my GitHub repository so you can see it. That's just at github.com/DamienEdwards next to all the other SignalR demos that I have. I'll create a new repository called dotnetConf 2014. Okay. And that's pretty much the crux of all this code. That was pretty much all it took to create an application that has a web client over here and a Windows Phone client over here that can talk to each other using these different APIs. Hopefully there's some interesting stuff in there that you haven't seen before and using our APIs, like how to do a little bit more reliable connection management, even though we try and keep it up as best as we can under the covers. And also a little bit of a look into how you might use SignalR with a more structured UI pattern, something like Angular in JavaScript, and my sort of made up MVVM model inside Silverlight. Now you could obviously use an MVVM framework like MVVM Lite or Prism, whatever the framework it is that you use, but you've seen a little bit more of that now here. So I have a minute or two left to take any questions if people want to ask them. Otherwise, I will prove that it still works. It does still work. And otherwise, I think I'm pretty much done. So let me just bring up that URL so you can see it. I'm going to post the code up on github.com/DamienEdwards. It'll appear here in the next hour or so. If you have any more questions, feel free to ask me a question on the GitHub repository. Otherwise, thank you very much.